What are we doing today?
Fisher's sign test. Well, if you've got to pick out the differences between the Wilcoxon sign round test and a Fisher sign test, what difference do you see?
This one's made by a guy named Fisher.
Okay, very good. This one is made by a guy named, or P. Fisher derived it, Ronald Fisher, okay. What else? What else is missing?
Right.
Rank. So in Wilcoxon's sign rank test, we paid attention to the signs and we paid attention to the rank. Fisher's sign test is actually simpler than that. It doesn't even account for the ranks, it just simply looks for the signs, positive or negative. So again, the test definition is null theta equals to something. The alternative could be one of three choices, not equal to 0, theta greater than 0, theta less than 0. Three possibilities. Depending on the test, we are going to have either a right tail test, left tail test, or a two tail test. What is the test statistic? Before we get to the test statistic, we have to define the difference. It is key. So we'll call it ZI. ZI is simply, you could do before minus after minus before. We stuck to after minus before for the most part, post minus pre. And we can use an indicator variable or just count the signs. But since we're dealing with numbers, let's define an indicator variable, just like last time. If the sign of Z is greater than 0, positive, we assign 1. Less than 0, we assign negative 1. Good. So the test statistic is simply the sum of all the size. Well, if you sum all the size, what are you summing? The number of what signs? Look at that indicator function and tell me positive signs. That's all you're doing. You're adding all the positive signs, just like Wilcoxon sign round test. We will stick to the positive side. Of course, you can do it with the negative, doesn't matter, but we'll stick with positive. Under the null, because we are looking at the null distribution, our assumption is theta equal to 0. In other words, no difference at all. If there are no differences, then what should be the behavior of the plus signs and the minus signs? Let's say I have a sample of size 8. How many plus signs should I have? How many minus signs should I have?
It should be
Evenly distributed, 50-50. If I had 4 positive signs and 4 negative signs, there is no difference at all. If I have more of positive, then depending on that definition, it'll either be left tail or right tail. Does that make sense? So the test statistic will have a null distribution depending on the fact that it has to be symmetric, important word. 2, it can either be plus sign or minus sign. So what is an appropriate distribution that you can think of?
Binomial.
Okay, Gunnar says binomial. Do we agree with it? Or you always agree with them? Okay, so the reasonable distribution is binomial because binomial has success, failure, positive sign, negative sign. Great. I've required binomial to be symmetric. We know binomial depends on 2 parameters. What are the 2 parameters?
or
We need 2 things in order to compute anything with binomial. What are the 2 things?
Sample size.
Sample size and
So close.
small L, M, N, O, P,
I almost said it.
right? Great. Now, do we know P? Under the null, what should P be?
0.5.
0.5, very good. So the null distribution is simply n comma p equals 1/2 with a binomial distribution. The reasoning behind it is that there is no difference at all. The number of positive signs and the number of negative signs would be equal. In other words, 50-50 chance. Does that make sense?
So you're only paying attention to the signs and not the magnitude associated with the sign?
That is correct. That is the key difference between Fisher's sign test and Wilcoxon's sign band test. I don't care about how large the difference is, which was important to me last time because the ranks depended on the magnitude. But here, doesn't matter. All I care is if I get a positive sign or a negative sign. Good. Okay. The rest is the same. In other words, we come up with a test statistic. We know how to find critical values from a binomial. I hope you know that by now. If not, homework 1. What do we use to find the critical value? Calculator. What in the calculator? Inverse norm.
no.
No, that's one minus that, that's what I was.
1 minus.
No, I'm kidding.
Bro.
Binom what? PDF, binom CDF, right? We've got to use one of those, binom PDF, binom CDF. So we can, in a calculator, it is pretty straightforward. We can use R, come up with the critical value right away. Excuse me, in a computer, but with the calculator, we've got to use PDF and do what we did with chapter 2. Good with me? So, as always, there is large sample approximation. Anytime we have a large sample approximation, our objective is to convert the test statistic to a standardized test statistic. We subtract the mean, we divide by the standard deviation, And we end up getting the standardized test statistic. So we have the test statistic, which is T. Now we want to find the mean. Mean. Under the null, what is the mean? I know the distribution under the null is binomial, NP. N is N, P is 1/2. So what is the mean? Mu. 0. So binomial NP would mean you have 0, 1, 2, all the way up to N. Yes. Some probability between. So the average cannot be here. It has to be somewhere here, right?
Divided by 2.
Just the end.
Very good. How did you get that, Chris?
I cheated and looked at it.
Oh, but why then? Great, so the formula is N/2, but why? Katie is being honest. Go ahead, Peter. Mean of what?
Sales.
I know.
It's N times P. The mean of a binomial is N times P. So N times P, in our case, P is 1/2. N times 1/2, which is N/2. Good?
But that's only when it's exactly.
No, this formula is always true. N times P is the mean of a binomial. But in this case, we have P equals 1/2. So in this case, the mean is N/2. What is the variance of a binomial? Chris, what does the book say?
And divided by 4.
N divided by 4. Why, Matthias?
NPQ.
It is N times P times Q. In other words, N multiplied by the probability of success, which is 1/2. If the probability of success is 1/2, the probability of failure is also 1/2, which will give me N/4. Good. Have the mean, have the standard deviation.
What's
So.
If the probability of success is 1/2, the probability of failure is 1 minus 1/2, which is still 1/2. So the standardized test statistic, as always, is Z T minus mu divided by sigma. What is the distribution of the standardized test statistic? What do we use? What did we use in chapter 2, chapter 3? The standardized test statistic. What is the distribution of the standardized test statistic? T plus and T minus. Here it is T. I want to know what the distribution of the standardized test statistic is. When we did a large sample approximation for a binomial test, we used a specific distribution. Large sample approximation for Wilcoxon sideground, we used a specific distribution. What is that distribution?
Normal.
What kind of normal? Standard normal distribution. The critical values we found with inverse norm and the p-values normal CDF. So what is the distribution? Normal. Does that make sense? Good. Okay.